In this video, we will discuss another example of sketching the graph of a given function and using the function formula, right? So basically, we want to decide the increasing, decreasing intervals and also local maximum, local minimum values, uh, concave up and concave down intervals, and also inflection point, if there is any. Then after that, we can sketch the graph, right? So before we do that, let's try to recall all the connections first, right? So you are given a function y equal to f of x, right? You want to decide what's the increasing intervals. By our discussion, we know that increasing intervals happens when f prime of x is positive, right? We want to decide decreasing intervals. And for sure, before you do anything, you need to know what's the domain of this function, right? Domain is very important. So we want to identify the domain, right? If you have the domain, you can sketch the graph on the domain using the given information at decreasing intervals, where f prime of x will be less than 0. And also we want to decide the possible local maximum values, or possible local minimum values. Now, before we do that, you should know the critical number, right? Because if you have a local maximum or local minimum value, if that duality exists, then duality has to be 0, right? So see here, critical number. See here, okay, let C here be critical number, be a critical number of f, right? By solving to be positive or negative, you have collected all the critical numbers, right? So how do we decide? And so if f prime changes, so this is the first duality test, changes from positive to negative, which means our function go from increasing to decreasing, then you get a local maximum value, right? If you try to sketch a picture, it's something like this. Function go increasing to decreasing. If you look at this picture here, you can see that this is concave, the graph is concave downward, which means the second derivative should be less than 0, right? So the second derivative test says if you have f double prime of c less than 0, you get a local maximum value, right? The top here is the first derivative test. Use the first derivative to decide f of c is a local maximum or local minimum. And this is the second derivative test. I use the second derivative to decide f of c is a local maximum or local minimum, right? So for local maximum, if you have either, you can check use the first or second derivative test. First derivative test, all you need to check is the change of the sign of the derivative, first derivative, right? And for local minimum, just change it according, right? Then f prime changes from negative to positive. So this is the first derivative test, or f double prime of c here to be greater than 0. This is the second derivative test. So that's a local minimum which means your curve has to be concave up, which means the derivative is second derivative is positive, right? So now let's see. Okay, we haven't done yet. So for the intervals of concave upward, all you want to do is you look at the equation f double prime x to be positive, right? And for the intervals of concave downward, you look at the intervals you obtained by this inequality f double prime of x to be less than 0, right? And so that's basically how. And one more thing here is we want to decide the points of inflection. So solving for the concave up and concave down intervals, you will get some numbers at which the second derivative equal to 0. So if the concavity changes from left to the right side of this point, that's a point of inflection, and points of inflection. Okay, so now let's see an example, right? Let's try to discuss one more example, right? To get all the increasing, decreasing intervals and local maximum, minimum values, and also the concave up and downward intervals and the points of inflection. I eventually want to sketch the graph, right? So the function here, so follow the guidelines, right? Example here is c of x equal to x to 1 over 3 x plus 4. So that's clearly not a polynomial anymore, right? It's a bit complicated because now the exponent contains a fraction 1/3. So before we do anything, as I said, is you need to figure out what are the domain, right? What is the domain? Domain here is all real number, and from negative infinity to positive infinity, right? So that's not hard to see because third root, that's an odd power, odd fraction, right? No, odd root, right? And so let's try to do that. And first part, we want to find local maximum, minimum, if there is any, increasing, and decreasing intervals if there is any, right? Intervals. Sometimes the function is always increasing, so you don't have any decreasing intervals in that case. So how do we do that? You need to take a derivative and try to get quick numbers first. So c prime of x, so that's a product of two functions, right? You get, this is 1 over 3 x to negative 2 over 3 x plus 4 equal, no, plus x to 1/3, right? Okay, as I said, we don't like negative exponent, so we change it to a fraction if you have negative exponent, negative power, right? So this is x to 2 over 3. No, sorry, that's wrong. Yeah, go to the denominator, right? So a big fraction here, x to 2 over 3 times 3, and x plus 4. Then plus, we want to take the common denominator, right? So you get x to 1 over 3 times 3, x to 2 over 3 over 3, x to 2 over 3, right? And so this is what? This is 3x, so 4x plus 4 over 3x to 2 over 3, right? Now you can see that the derivative here equal to 0 when the numerator is 0, as I said, right? If you have a fraction is 0 if you have the numerator 0. So this equals 0. I dot Ex is -1. And C prime of X does not exist. Does not exist when the denominator equals 0. When 3x to 2/3 equal to 0, I dot E X is 0. So you still have two critical numbers. One is 0, the other one is what? Is -1, right? So these two numbers divide the whole domain into 3 intervals. You have what? You have from -infinity to -1, and from -1 to 0, and from 0 to positive infinity, right? You want to decide C prime of X is positive or negative. You can try to sketch a table here, right? Write down each factor. You have two factors, 4x plus 1, 4x plus 4, and 3x to 2 over 3, right? So x to 2/3 is x squared to the power 1/3, right? So which means everything will be positive. So from -infinity to -1. So this is negative, right? This is positive, so this is negative. And this is positive, positive, positive. So positive, 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 right? So you can see that f of -1, left side is decreasing, right side increasing, is a local minimum value. Now f of 0 is neither. Or on 0 left side increasing, right side is also increasing. So that's neither a local maximum or local minimum, right? F of -1, what's that? If you try to do that, f of -1 is 3, right? So f of -1, you plug a -1 into here, which is -3, sorry. So that's the local minimum value. We don't have local maximum, right? So that we get all the increasing, decreasing intervals. We have two increasing intervals from -1 to 0, from 0 to positive infinity, and also decreasing intervals from -infinity to -1, right? So that's very important. Okay. So that's good. Now I try to figure out the interval of concavities, right? So let's try to do that. So we want to figure out the second derivative, right? So we know that, okay, second part. Let's try to see that. Okay. So let's try to use our, okay, let's try to write down what we want. We want to find the intervals of concavity and points if there is more than one, or could be the right of inflection. So there might be, I may not be, so we just need to figure out, right? So we want to get a C double prime of X. And how do we do that? We have C prime, just differentiate that one more time, right? So if you try to use a product rule and things, or you want to do it, just do that, right? So this is 1/3 times -2/3 x to -5/3 x plus 4 plus 1/3 x to -2/3 plus 1/3 negative x2, negative 2 over 3, right? So that's basically what's going on there. And so let's try to see see when this is increasing and when this is decreasing, right? Just apply the product rule and the power rule. You can get this derivative, right? Not a very bad function to differentiate. The bad part is try to simplify this function, make it a fraction, right? So this is negative 2 over 9 times x to 5 over 3, 2 times x plus 4, right? Then plus, this is 2 over 3, so 2 over 3 times x to 2 over 3, right? Times, because what? Because you need to take a common denominator, so the times x here, then times x here, then times 3 times 3. We want to get a common denominator, right? And so this is equal to negative, okay, let's try to put negative all together, right? So this is negative 2x minus 8 minus plus 6x, right? 9 times x to 5 over 3. So this is 4 times x minus 2 over 9 times x to 5 over 3. Okay, right, because 6x minus 2x is 4. 4, 8, you have a common denominator, which is 4, right? And so this you can see that c double prime x equal to 0 when x is 2. C double prime of x does not exist when x equal to 0. So this could be an inflection point because left side, this CWX is positive, right side is negative. That could happen, right? So we have 3 intervals from negative infinity to 0, from 0 to 2, from 2 to positive infinity, right? And try to decide each factor, this factor and this factor, positive, negative. We can see that C double prime of x is positive because both factor will be negative, and a negative because one of the factor is positive, the numerator is negative, right? The other one positive and positive. So which means C of x, the graph here is concave upward and concave upward and concave downward, right? So we have 2 inflection points. So f of 0 equal to 0. So that's the inflection point, which means 0, f of 0 is an inflection point because left side of 0 concave upward, right side of 0 concave downward, right? So that's the inflection point. And the other one is 2. F of 2 will be 2 to 1/3 times 6. So that's another inflection point. Inflection point. Right? We have 2 inflection points. One is left side concave up, the right side concave down. The other one is left side concave down, the other side concave up. Right? Okay, now let's try to sketch the graph of this function, right? Third part, sketch the graph of the function. So how do we do that? Try to draw our x-axis, y-axis, label all the important points, right? So you have a local minimum happens at -1. So this is -1, y value is -3, so that's a local minimum. f of 0, 0. So 0, 0 is the inflection point. Inflection points. The other inflection point is 2, some number, right? Positive for sure. So this is 2, 2, 2, 1/3 times 6. So that's another inflection point. And from negative infinity to -1, concave up, right? But decreasing. So that decreasing, right? Let me use black to sketch it. Then on the right side of -1, still a function go to increasing, always increasing, but still concave up. On the right side of 0, still increasing, but concave downward. On the right side of 2, still increasing function is concave upward. So that's the graph of this function, y equal to x to 1/3 x plus 4, right? Using the property of the derivatives, we can figure out all the increasing, decreasing intervals and concave up and concave down intervals, and also local maximum, local minimum values, inflection points. We can eventually sketch the graph of this function roughly.